So now, after looking at difference of squares and the patterns that they can factor into, we're going to look at a different kind of pattern. Okay, now we're going to move on to a second kind of pattern, the kind of pattern that results from having expanded something like this, right? And we know if we were to say that x plus 3 squared is x squared plus 9 because the square of x is x squared and the square of 3 is 9, we would immediately check ourselves and say, no, that kills small puppies. We don't like to do that. So what this really means, of course, is x plus 3 times x plus 3, which is, of course, x squared plus 6x plus 9, right? If we looked at a couple more examples, right, x minus 7 squared, x squared minus 14x plus 49. Something like 4x minus 3 squared would give us 16x squared minus 12x, so minus 24x plus 9, and maybe something like 2a plus b all squared would give us 4a squared minus 2ab minus 2, or plus 2ab, so plus 4ab plus b squared. Right? We have a name for this result. We call it a perfect square trinomial. Right? Trinomial, of course, because it's 3 terms, and we notice this pattern. Right? Again, it's all about noticing the pattern, so that you, in order to factor it, you can just fall back on the pattern and say, well, I know what's going on here. All of these, right, start with a square and end with a square, right? X squared is a square, 9 is a square number, x squared, 49. 16x squared is the square of 4x, right? We can actually look back and see where it came from. 9 is the square of 3. 4a squared is the square of 2a. b squared is the square of b. Right? So that's part of the pattern. It always starts and ends with a square. You'll notice that the middle term is actually also significant. The middle term is always double the product of the two things where the squares came from. So, for example, here we have x and 3. 3 times x is 3x, doubled is 6x. Negative 7 times x is negative 7x, doubled that's negative 14x. 4x times negative 3 is negative 12x, doubled is negative 24, etc. Right? 2a times b is 2ab, doubled is 4ab. So this middle term, this b term, every time is always double whatever we got our squares from. So again, if we were to look at a broad definition of what a perfect square trinomial might look like, we would say, well, it looks like a square, ends with a positive square, and in the middle it's either plus or minus double whatever those squares came from. Right? So that's the pattern, and it would always factor down to, if we're going to work from the simplified form to the factored form, it would always work down to plus or minus the thing that the squares came from. So m squared is the square of m, n squared is the square of n, right? And this middle term would always be double whatever those two things multiply to. So that would be the pattern we'd be trying to recognize. How do you recognize it? Well, it is a trinomial, so it might look like a simple quadratic or some other kind of quadratic, but you need to be able to spot. You need to be able to spot that those are squares, right? They might have a square on a variable, or it could be a square number or something with a square coefficient, right? That's going to be your clue. So a couple of examples then. X squared plus 16x plus 64. Is this a perfect square trinomial? Well, yes. X squared is a square, 64 is a square. What are those things squares of? Well, they're squares of x and 8, right? How do I know it's plus? Well, if this is plus, then this is plus. Am I right? Well, let me just double check. I know I'm correct. If x times 8 doubled is this number, oh yeah, 8x doubled is 16x. So that is correct. That's how it goes. So we'll just run through some more examples. 4x squared plus 12x plus 9. Well, let's see. I definitely know that 4x squared is a square. It's the square of 2x. 9 is a square. It's the square of 3. If this is right, then That works out double of whatever 2x times 3 is. Looks pretty good. This example, 16a squared minus 8a minus 1. Well, it looks pretty good, right? 16a squared is the square of 4a. 1 is the square of 1. There is a problem, right? This is a minus 1. A square can't be a negative number. So as it stands right now, that is not factorable, especially as a perfect square trinomial. There, 16a squared minus 8a plus 1. Now we've got something we can probably work with. 4a is what that is the square of. 1 is what that is the square of. This is a minus 8, so this would be a minus. Check, right? 4a times negative 1 is negative 4. Doubled is negative 8. Looks good. This one, 36x squared plus 48x plus 16. Now, well, I do know that 36 is a square. I know that 16 is a square, so I might be tempted to say, well, this looks like it must be 6x plus 4 squared. And I think actually, if I were to FOIL that back out, that would be correct. Now, problem is that I have here a factor, right, 6x plus 4, that still has a common factor, right? There's a common factor of 2 still in there. So if I really wanted to work with that, I would say, well, I know that this is 6x plus 4, but I know it's not factored all the way out. I still have to take a 2 out of the front one and say that's 3x plus 2, that this is 3x plus 2 with the 2 taken out as well of the second factor, and that equals 4, 3x plus 2 squared. This would be fully factored. Now, I can avoid all this and avoid maybe, stopping after the first step and thinking I'm done if I, as I mentioned before, recognize that there's a common factor and I really, really want to take that common factor out first always, right? So this expression, if I was to take out a common factor, well, it looks like 4 is a common factor. And if I take that out, I get 9x squared plus 12x plus 4. And lo and behold, I still have a perfect square trinomial, right? 9 is a square number, 4 is a square number. And so to finish this off, I think I can do this. And that's, I think, a lot easier way to get there. Maybe the one last one, right? How about this? X squared plus 16xy plus 49y squared. Looks pretty good, right? Starts with a square, ends with a square. Let's see if it works out. That would have to equal then something in this pattern. X plus 7y. I will want to double check, right? X times 7y is 7xy. Doubled is 14xy. Oh, that is a problem. Maybe I was just trying to fool myself by giving myself this example. X squared plus 16xy plus 14y squared is not a perfect square trinomial, so therefore it doesn't factor that way. And we would probably just write, instead of a solution, we'd write DNF for does not factor. So by now in this unit, we've covered how to do common factoring, we've covered how to do simple quadratic factoring, we've covered how to do differences in squares factoring, and perfect square trinomial factoring, right? All of these will only pop up with the simple instruction factor, right? So it's up to you to be able to recognize them. If you recognize the pattern and know how to do it, then they factor very quickly and very easily.